Hello and welcome to section 5.4, which is on medians and altitudes. The median of a triangle is the segment whose endpoints are a vertex and the midpoint of the opposite side. And I'm going to show you an example here in a little bit. Theorem 5.8 is a concurrency of medians theorem. The medians of a triangle are concurrent. That means they cross each other at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. The centroid of the triangle is the actual point of concurrency of the medians of a triangle. So where they cross, the point where they cross is called the centroid. So the median down here would be from X over to B. So it's from the vertex and then over to the midpoint of the opposite side. Okay, so that's a median. This one here from Z over to C is a median, and from Y to D is a median. And so the point A in the center right here is the centroid. It's the point where all three of them cross. And this theorem here is saying that they cross at a point that is 2/3 of the way from each vertex to the midpoint of the opposite side. So this, from X to B, this point A is 2/3 of the way across. And knowing that, we can solve this question then. It says ZA is 9. So from Z to A, which is 2/3 of the way across, is 9. What is the length of the whole thing from Z to C? Z to C. Because we know that's 2/3, we can solve that. And so what we would do is say that ZA equals 2/3 of ZC. And because we don't know that ZA is 9, I can plug that in. So 9 equals 2/3 of X or ZC or whatever. We'll just call it ZC. And so then to solve for ZC, you would divide, but you can't because it's a fraction. So instead, you're going to multiply by the reciprocal. So multiply times 3/2 gets rid of that. Come over here and multiply by 3/2. So you'd get 27 over 2, which is 13.5. So that equals ZC. So knowing that that point A in the middle there, right here, knowing that is 2/3 of the way across, I can solve then what the actual distance of the whole median is. The altitude of a triangle. The perpendicular segment from a vertex of the triangle to the line containing the opposite side.
This is Feldhouse, telephone line 1. This is Feldhouse.
Okay, so theorem 5.9 says that it's the concurrency of altitudes theorem. So the altitudes will not always go to the midpoint of the other side. It depends what kind of a triangle it is. So it's an altitude. The lines that contain the altitudes of a triangle are concurrent, meaning they will cross. So this point of concurrency is called the orthocenter of the triangle. And some of that got covered up because I moved my, must have hit enter up here. There. So for triangle ABC, is each segment a median, an altitude, or neither? And how do I know that? So first we're going to look at AD. So from A, which is a vertex, across to D, and if you look at what's shown here, it's showing that these two segments are equal to each other. So what do we call that when it goes from the vertex to the midpoint of the other side? That is a median. Why? Because it connects the vertex right here to the middle of the other side. That is a median. Median means middle, right? EG. So from E over to G. Well, it doesn't start at a vertex at all, right? And we can't really say that that's... We know that E is the midpoint from A to C, but G isn't a midpoint, so we can't call it the midpoint of the triangle either. So on that one, we're going to have to say it's neither. It's not a midpoint or an altitude. It doesn't start from a vertex, so. And CF is the other one, so from C over here to F, it's not to the midpoint, so it's not a median, but there is a right angle right here which shows that this line here and this one are perpendicular. So that would have to be an altitude. So there it kind of shows the difference between a median and altitude. Another example, and this is a rather involved one, but just pay attention, stick with me, it'll all make sense in the end. So find the coordinates of the orthocenter of the triangle. Orthocenter, remember what that was up here? The point of concurrency is called the orthocenter of the triangle, where all the altitudes meet. Remember, the altitudes have to be perpendicular. That's another key point of this. So I have already graphed my points. Here is A, here's B, and here's C. So find the equations of two of the lines containing an altitude for the triangle. And I already have a little hint here. AB is going to be the easiest since it's a horizontal line. It already is like this, right? And so to do the altitude of that, I just have to make it perpendicular, right? Okay, so the altitude from this vertex here, that is a really big line. Let's try a regular line. So from here to there, that is a 90-degree angle. So that is the altitude. And so that's going to be the easiest equation to find, because where does that, what's the equation? 1, 2, 3, 4, 5, 6. That equation is where y equals 6. So x equals 6. Okay, because that's right here. X equals 6 right there on that line. That's how we can do that. So now, BC, you need to find the slope of it. And if you remember from chapter 3, to find slope, you subtract your y's. And so 6 minus 2 will go on the top. The y's right here. And then the x's will go on the bottom, 8 minus 6. So I have 4 over 2, so my slope is 2. I better draw on this A, B, C. So if my slope is 2 from B to C, the line that would be perpendicular to that would have a slope of the opposite reciprocal, so negative 1/2. And so I can use one of these points Okay, so I have to use point A. Why do I have to use point A? Because I'm trying to figure out what line is perpendicular to BC right here that goes through A. I need it to be perpendicular when it comes across. So I have to use point A when I'm doing the point slope form. So my point A was at 2, 6. So y minus my y, which is 6, equals my slope of negative 1/2 times x minus 2. So I can go ahead and simplify this right side. 1/2 times x, so negative 1/2 x. And then negative 1/2 times negative 2 would be a plus 1. And then I have y minus 6 still on this side. And I'm going to go plus 6 to get rid of it and move it over here. So y equals negative 1/2 x plus 7 for the equation of the line that would be perpendicular from this corner across. Now I have my two equations. So y equals negative 1/2 x plus 7, and then my other equation was x equals 6. So since I know that x equals 6, I can plug it in right here. So y equals negative 1/2 times 6 would be negative 3, and then plus 7. So y equals 4. So my orthocenter is at 6, 4. Once I find my x, I just need to find my y. And I could go back up here and check that. Would that work? Where is 6, 4 at? It's right here in the center. And so if I drew a line from this corner through that orthocenter that I just found, does this look perpendicular right here? It sure does. So that point right there in the middle, 6, 4, is my orthocenter. Did that require a lot of steps and some effort? It sure did, but we have all of the building blocks to be able to do this. What I did there at the end was solve a system of equations, right? Right here, I had a system, this one and this one, and then I just solved the system to get my final answer of 6, 4 right there. So bring that knowledge with you. We'll talk about it more the next time I see you. Have a good night.